Welcome to today's video, where we're going to explore a fascinating topic in the world of Julia programming recursion. Specifically, we'll be discussing why recursion in Julia sometimes gives answers in an array of arrays form and any type instead of matrix form and Int64 type. If you're new to Julia or programming in general, don't worry. This video is designed to be informative and easy to follow. We'll break down the complex concepts into simpler parts, using examples and analogies to help you understand the material better. By the end of this video, you'll have a solid grasp of why recursion behaves this way in Julia and how to work with these types of results. So let's dive right in. So what is recursion in simple terms? Recursion is a programming technique where a function calls itself repeatedly until it reaches a base case that stops the recursion. In Julia, when we use recursion, sometimes our answers come back in an array of arrays form instead of a neat matrix. Why does this happen? Well, it's because Julia is a dynamically typed language, which means it doesn't know what type of data you're working with until runtime. When Julia encounters a recursive function, it tries to determine the return type based on the function's output. However, when the return types are not uniform, for example, if some branches return an integer and others return a float, Julia will default to using the any type. This is because any can represent any possible type in Julia. But why does this result in an array of arrays instead of a matrix? The reason lies in how Julia represents matrices internally. Matrices are essentially 2D arrays, but when Julia sees a recursive function returning an array of arrays, it doesn't automatically convert it to a matrix. Think of it like a tree data structure. Each branch can have its own sub-branches, and these branches might not be uniformly structured. In the same way, Julia's recursion results in a nested array structure that reflects this non-uniformity. Now, let's consider an example to illustrate this concept. And suppose we're trying to generate all possible combinations of numbers from 1 to 5 using recursion. Our function might return an array of arrays where each subarray represents one combination. In Julia, when you try to combine these results into a matrix, you'll end up with an error because the subarrays have different lengths or type. This is exactly what's happening in our original scenario. The recursive function returns an array of arrays that can't be directly converted to a matrix. So, let's recap the essential points we've covered. Recursion in Julia sometimes gives answers in an array of arrays form and any type because of Julia's dynamic typing. The return types are not uniform across all branches of the recursive function. This results in Julia defaulting to using the any type for the return value. The nested array structure represents a non-uniform tree data structure, making it difficult to convert directly into a matrix. And that's a wrap on today's video about recursion in Julia. I hope this explanation helped you understand why sometimes your recursive functions give results in an array of arrays form and any type instead of matrix form and Int64 type. If you have any questions or topics you'd like us to cover next, please leave them in the comments below. We'd love to hear from you. Don't forget to like this video and subscribe for more informative content on Julia programming. As a final call to action, try experimenting with recursion in your own Julia projects and see how these concepts play out. You can also try converting recursive functions to iterative ones, or using different data structures to represent the result. The possibilities are endless, and we're excited to hear about your discoveries. Until next time, happy coding!